Hello everyone, myself Nikhil. Today I am discussing about the Fourier transform and its applications. First we learn about the contents, introduction, properties, FFT, limitations and challenges and conclusion. First we learn about the introduction of Fourier transform. The Fourier transformer is a mathematical tool used to analyze and decompose the complex signals or functions into a combination of simpler Sincere functions. It was introduced by Jean-Baptiste Joseph Fourier in the early 19th century. The Fourier transformer has an application in various fields like signal processing, image analysis, audio comparison, and quantum mechanism. Definition of Fourier transformer. The Fourier transformer of a function f of x is given by the equation f of k is equals to summation f into x e power minus 2 pi I x into dx, where f of k represents the transform function in the frequency domain. It transforms a function from the time or septal domain of the frequency domain. The Fourier transform can be applied both continuous and discrete function. Properties of Fourier transform. Linearity property. The Fourier transform of a linear combination of functions is the same linear combination of their individual transform. Time shifting property. Shifting a function in the time domain corresponds to phase modulation in the frequency domain. The scaling function is the time domain leads to a corresponding scaling in the frequency domain. The properties of the Fourier transform you can see in the image. First Fourier transform FFT. The first Fourier transformer is an efficient algorithm for computing the discrete Fourier transform DFT of a sequence or a discrete function. It reduces the computational complex of the Fourier transform from 0 n of 2 to 0 n log of n, where n is the number of samples. The FFT has resolution may applications that requires real-time signal processing or in a large-scale computations. Introduction to Fourier transform applications. The Fourier transformer is a mathematical technique used to analyze signals and systems in the frequency domain. It is in various applications in real-world sensors, making it an essential tool in fields such as engineering, physics, and as telecommunications. These presentations will explore some of the key applications of Fourier transformers in real world. The image and video processing. Fourier transformer is widely used in image and video processing for tasks such as comparison, filtering, and ethical element. It allows for essential comparison by representing the image and video in the frequency domain, removing the redundant information. Filtering operations such as noise reduction or sharpening can be performed by maintaining the frequency components of signals. You can show in the figure. Audio and music processing. Fourier transformer play a virtual role in audio and music processing applications. It enables the tasks such as audio comparison, equality, and path detection. By transforming the audio signals into the frequency domain, we can analyze and manipulate the different frequency components, leading to various audio effects. Signal analysis and spectrum analysis. Fourier transformer is an externality used for the signal analysis and spectrum analysis. It helps in the definitely the frequency components present in a given signal. Spectrum analysis allows for the identification of dominant frequencies or the presence of specific parents in the signals, adaptive in various applications like speech recognition and variation analysis. Communication system. Fourier transformer is a fundamental to the design and analysis of communication system. It allows for the modulation and demodulation of signal, enabling the efficient transmission and replication of data. The Fourier transformers also helps in signal equation, channel estimation and error correction techniques in the communication system. Medical imaging. Fourier transformer is used in medical imaging techniques like magnetic resonance images, MRI, and the computed CT scan. It helps in the recognizing the image from ray data equated by the imaging techniques. Fourier transform aids in an ethical analysis of the medical image, assigning in the diagnosis and treatment planning. Radar and sonar system. Fourier transformer is utilized in radar and sonar system for the target detection and range estimation. By analyzing the frequency components of the reflection signals, these systems can identify and locate target accurately. The Fourier transforms also assistance in noise reduction and interference rejection in radar and sonar applications. Quantum mechanism. Fourier transform fits applications in the quantum mechanisms for the solving the solderings of equation. It allows for the analysis and manipulate of the wave function, leading to a better understanding of quantum system. Fourier transforms adds in the calculation of the energy spectrum and the wave function. Limits and challenges. The Fourier transforms assumes that the signals are stationary linear and have the infinity duration, which may not always hold true. The presence of noise or non-linearities can affect the accessories of the Fourier transform. Choosing the appropriate window size and dealing with the edges effects are some common challenges in Fourier. Conclusion. The Fourier transforms has a wide range of applications in various fields, including images and videos and processing the audio and music processing, signal analysis, the communication system, imaging, radar and the sonar system, specs and audio comparison, and even quantum mechanism. It is a variability of the Fourier transform makes it an independent tools in the real world. Thank you.